Did you know that the average person has one fallopian tube? Well, that's a problem with statistics to some extent and how we interpret them. So you need to be smart when we think about statistics. We're going to be talking about statistics, experimentation, studies, research a little bit today. Here's another one that's important about statistics. I like this one. 5 out of 4 people struggle with math. Okay, so let's move on a little bit. So I heard this on the news a little while ago, that they're pirates in the Indian Ocean, like in that movie Captain Phillips with Tom Hanks. And they're real pirates out there, and some of the captains have found that if they play Britney Spears music very loudly, that they get attacked less, or they think they do. That's a conclusion, and they're doing their own little research on the spot in real life. But is it really true or not? Well, there's a problem with that. One of the problems is there's no control group. There's no comparison to something else. What if they're playing Mozart? What if they're not playing music? We need to do that. And of course, they can't do that in real life, in real time. But that's something we should be thinking about as we study psychology and use scientific methods to be neutral and objective about things. So there are some things in studies that are important to do. And one of those is defining our terms. We use what we call an operational definition. An operational definition is the specific operations, how we're going to define the terminology and variables that we're going to study. We need to be very specific and objective so that other people know what we're talking about and they can repeat that. That's called replication or verifiability. Some sciences or some areas that call themselves science are not scientific in their methods. For example, astrology. Here's an example. Let's use Gemini. That's me. I was born in June. So according to this, this is from June 1st. Each day of the year, I guess it's different. This says, diversify, experiment with different modes of transportation. You'll be asked to entertain, to help promote charitable or political project. Seems interesting, but what does that mean? It is not a specific definition that can be put to a test, so it's not scientific, and it's just fun to play around with, but don't take those things seriously. How about your birth year? Your birth year, the Chinese zodiac. This was found from Panda Express. Oh, well, they're a scientific institution, aren't they? Okay, well, so let's take a birth year. Let's pretend you're 18 years old now, so that means you were born somewhere around 2002. 2002, that puts you are the year of the horse. So if you were born in that year, you're the year of the horse. The horse is well-liked, happy, thrifty, funny. This is a description of your personality. Again, it's fun. It's not scientific because how do we define those things? How do we put these to a test to decide, is it accurate, is it not? Does the evidence support it or does it not? Well, I found a psychic who made predictions that were relatively scientific. They had operational definitions, they were testable, and lo and behold, none of them came true, which shows how valuable that is. And of course, that's why many of these people aren't going to use specific scientific methods, because it's going to show that they're just not accurate in predicting the future. But it's fun. These were for the 1990s. It's pretty old. But in the late, probably 1989, here are some of Countess Sophia Sabak's predictions. In 1996, Hawaii will sink into the ocean. A teenage science nerd will accidentally explode a homemade nuclear bomb in Pageland, South Carolina on May 23, 1994. That was pretty specific. We are just missing the person's name and their address. But, and of course, neither of those happened. And the Cleveland Indians didn't win the World Series in 1992 like she predicted. They were pretty bad back 20 years ago or so. So we need operational definitions of our terms. As I said, that's something specific. So let's talk about some specific types of research studies that we would do. Okay, you need to start with a hypothesis, which is a prediction or a guess about what variables are going to be related and might cause another one to happen. Sometimes, though, you don't have a lot of control, and you simply can measure the variables, and that's what we call a correlation research study. You're measuring at least 2 variables and seeing if they seem connected. And by connected, I mean if one gets higher, the other one gets higher, or one gets lower, the other gets lower, or an opposite inverse relationship. One gets higher, the other one gets lower. that that latter situation would be what we would call a negative correlation. Positive correlation means they're going in the same direction. So height and weight, as we're growing, as our height gets tall, as we get taller, as we're growing, our weight tends to get higher. Exercise and weight might be the opposite, particularly in an adult. You exercise more, weight goes down. So that's opposite. That's an opposite relationship would be negative correlation. Of course, if they're not really connected at all, it's pretty low number, and we can do numbers on this. I'm not going to get you into the math about that, but there's statistical ways that we use. But we're really just measuring two things, and do they seem connected? That's it. It's not going to address whether one causes the next to happen. You need to do something very different. Here's an example of what might be a negative correlation. I'm just making this up, so it's just a good example. Here you have GPA, grade point average on one axis, and the other axis, MJ, marijuana use. So 0 to 10, I just made up some numbers. So as you can see, according to this is a negative correlation. One goes up, the other one goes down. As we start using more marijuana, grade point average goes down, and vice versa. So what that means, if one goes up, the other one goes down, it's a negative correlation. This hypothetically is a guess about what we might see if we actually did some research. College students have been known to do their own research sometimes. I'm not going to get into that one, but maybe you might think otherwise there. Well, let's do another drug example, for example. Let's say you have ADHD students. ADHD students who maybe medication is helping them. The more medication they use, it's a drug of a sort, but it's a prescription, the better their grade point average. This would be a case for why some people would use that. Now, there are other research studies which do let us make conclusions about cause and effect, one thing causing the next. And that's what we look at in psychology if we can. We look at whether one variable seems to cause a change in another, and then we try to apply it in the real world. We call these independent and dependent variables. Independent variable is the variable that the researcher controls, often with two groups at least, and each group is getting a different kind of that variable, and then we're going to measure something, the same thing for both of them, which is called the dependent variable. Let me give you some examples. Drug studies, medication studies. You've got two groups of depressed people. What you're doing is everything, they should be treated the same, they should be separated out so the groups are relatively the same, and there's a way to assign group members, so you're basically making the teams even, or the groups even. We're going to do one thing different, we're going to give them different medication, and of course with placebo effects we have to disguise that. That's called doing a blind study, either single or double blind. I'm not going to get into that right now, but you can look it up more in the book. So you give different medications. So one group gets Prozac, another group gets Wellbutrin, two antidepressants, and we measure them on depression before and after, and we look for changes. Does one group change more than the other in a positive direction? Well, now we can make a conclusion that the independent variable, which is the type of medication, caused a change in the dependent variable. That dependent variable depended on the independent variable in our hypothesis and our stats. And so we can make that conclusion based on this. In this kind of study, it's called the experimental method, often done in an artificial setting like a laboratory or a psychology department, sometimes in a classroom when we're doing survey research, but it's often not done in the real world because you need a lot of control. The advantage of this is that you can make some strong conclusions about one thing causing a change in the other. Now, of course, you do have to control a lot of those other variables that might affect the results. So, for example, what's happening to all these people who are depressed in their life outside of the research study? Do some of them have depression for longer time periods than the other? You have to have a way to even out these groups so that none of those things are factors. We call those things extraneous or control variables, and there are various methods. But if you use those and control for those, really the only difference between the two groups is the independent variable that they received. One got a different medication than the other, and therefore if you see a difference, it is fairly attributable to that independent variable, that different medication. And of course, it's not a perfect relationship you'll see in one study or many studies over time, but it allows you to say that the evidence supports that this is a factor in causality, cause and effect. Here's an example. Let's pretend well, this is based on an old Roseanne Barr joke. Roseanne from the TV show, and she used to do stand-up comedy, and she had an old one-liner saying that she found out that there were men dressed as women and they could no longer parallel park. Yes, it's very stereotypical, gender stereotyping, but let's just go with that as an example. Okay, so men dressed as women, do they have trouble parallel parking compared to men dressed as men? Okay, so here's what it might look like. Independent variable in the experiment. Dependent variable, that's what the IV and the DV stand for. So group 1, MDM, men dressed as men. Then we measure them on parking. So the what group we put them in the experiment is up to us, up to the researcher. So that's what you control, the independent variable. What we're doing in this research study is we're probably getting research subjects to volunteer, and we're dressing them in the way that we decide, not what they decide. So we're doing an experiment. We are controlling the independent variable. That's the manner of dress. It's the only thing that's going to be different between these two groups. And then dependent variable, we just measure, see if there's a difference. And there's statistical ways to do that. MDW, men dressed as women, that's group 2. And they're also being measured on parallel parking. So both groups measured on parallel parking, the dependent variable. Each group, different level of the independent variable, and that allows us to conclude about cause and effect. One of the problems, of course, with this is that it's not the real world. So in the real world, you get men dressed as women who choose to do that, not because they are told to do that in a research study. And so you probably want to study that in the real world if you could. For practical reasons, this example probably wouldn't be very easy to study in the real world. You'd have to observe people, and then again, you can't control things. So there's pros and cons of these things. Again, correlation research does not deal with cause and effect, but it often is the best that we can do. Whereas an independent variable, dependent variable, experimental method study does address cause and effect. We can make stronger conclusions, but we have to do it in the lab often, and it requires more control and somewhat of an artificial setting. So these are some of the things we're covering with research. We'll see you next time. Take care.